3-5, proving lines parallel. This is exactly backwards of the other day. So if you know your alternate interiors, your alternate exteriors, and if you know the parallel lines make them congruent or whatever, then this is super easy. It's just backwards. On the back, if you jump there really quickly with me, you see number 25. Okay, that's a proof. We've skipped chapter 2 this year because of I-STEP, and I want to make sure that you guys know what you need to know before that because there are no proofs on I-STEP. So we will be doing proofs. We will be coming back to them, but not now. So anything that looks like that, we'll be skipping for a little bit, but we'll come back to it someday, just not today. So proofs are important. It's a huge part of geometry, but it's not part of that I-STEP. So because I have time to skip it, I'll skip it and we'll come back later. Okay, so go back to the front with me, please. Today we're proving lines parallel without actually proving it. We're not doing any proofs, sort of. So postulate 3.4. If two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. The other day we said if two lines are parallel cut by a transversal, then what did we just say? Which angles? Then corresponding angles are congruent. Today they're saying if corresponding angles end up being congruent, then the lines that made them had to be parallel. Do you see how I'm basically saying the same thing but in a different order? Does that make sense to you? Remember the first day I showed you angles and I told you these are alternate interior and they just had a name. They didn't necessarily have a relationship yet. Remember that? They still have a name. Today, the second day, we said, hey, if these are parallel lines cut by transversal, then these corresponding angles are congruent. Today I'm going to say if you have corresponding angles and they are congruent, then the lines that made them had to be parallel. Those all essentially say the same thing but in a different order. Okay? So theorem 3.5. If two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then those lines must be parallel, right? This one is our weird one, the supplementary, right? If two lines in a plane are cut by a transversal so that consecutive interior angles are supplementary, the lines had to have been parallel, right? Alternate interior. If two lines, they had to be parallel. You guys see what I'm saying? So if two lines in a plane, any two lines, let's pretend I don't know that those look parallel, right? Two lines in a plane are cut by transversal. I don't know those are parallel because there's no arrows on them, right? Like these arrows. Like that. I don't have those on there. So if I have alternate interior, oh, they said alternate interior, just kidding. I don't want that one. Let's do 1 and 2 here. If I tell you that these are congruent, then line A and line B had to be parallel. That's what that's saying. It's the exact same as the section before this, but backwards. Okay? And then 3.8. In a plane, if two lines are perpendicular to the same line, then they are parallel. It's the exact backwards of that other postulate, right? And then the last one, parallel postulate. This is kind of hard to understand without a picture, so just give me a second. If you're given a line and a point not on the line, point not on the line, okay? If you're given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So line, point. If this is what I have, there's only one line through point P that's parallel to L. There's only one line that exists that satisfies that condition. Does that make sense to you? So I can't do this line, that's not parallel, right? Just this one line through the point they gave me is parallel. Is that okay? Okay. We're going to do a couple. It's super easy. I know it seems confusing because it's so close to the same, but it's actually really easy. Okay? Which lines, if any, are parallel and why? Okay? You have a pencil with an eraser. Yes, because it's math class. Good. Okay. So what we're going to do is we're going to go ahead and identify where these angles are and then erase it and do a whole new set, right? So angle ABC is this angle right here, right? Angle FDK, where's the F? FDK is that one right there. They said those two angles are congruent. No matter what, those two angles have a name. What's their name? Alternate interior, alternate exterior, corresponding consecutive interior, maybe vertical, maybe linear pair. Alternate exterior. They have a name. Their name's alternate exterior. Because they ended up being congruent, that means that two lines had to be parallel. Does that make sense? So now here's the trick. What two lines are parallel, right? So I think for some people this is kind of hard to do. Maybe find their transversal first, and it's not that, right? So what is the transversal for those two angles? What touches both of them? P, right? So it's not P, so it's got to be those other two, right? So I said line CG would be parallel to what line? EJ. See how I have a double-headed arrow? You got to start doing that right, okay? So CG line would be parallel to EJ. I could have called it CB. I could have called it CH. Those are all the same line. You guys get that, right? As long as you put a double-headed arrow over it, they're all referring to the same line. It also said Y, so I'm just going to say alternate exterior angles. That's fine. Okay. It's because of which postulate or theorem was that? Which one was alternate exterior? 3-5. It's because of theorem 3-5. But and here we don't memorize those. That's not really super helpful. I would just give it a name. Is that okay? Okay. So let's erase that one and draw our new one. All right. Try to beat me to it. You guys need to locate angle EDB and angle DKH. All right. EDB congruent to DKH. DKH. All right. What is their name? Corresponding. And they're congruent. Therefore, two of these lines are parallel. Okay? You guys just said corresponding, right? What two lines are going to be parallel because those two angles were congruent? P is parallel to Q. What's their transversal? This line, right? Like EJ? So it's not that. It's going to be these two. You can call it lowercase cursive p, lowercase cursive q. You could have called it like AF and I, is that an IL? An IL or something like that. But P and Q is probably quicker. Do you get those are corresponding angles, the name? No, you don't. They're both to the left of the transversal and above the parallel line. So they're in corresponding positions. They're not alternate interior. They're not alternate exterior. They're not consecutive. You see what I'm saying? So you could process of elimination probably your way there. But those are corresponding. And then these two are the parallel lines, and that's the transversal. Do you see that? Okay. We'll do some more. I think it'll be okay. All right, you guys go ahead and find these two angles. Locate those two. Erase what we just had. So we're doing HKD. HKD is this angle. And FDK. Where's F? FDK. This one. What's their name? No matter what, they have a name. What is it? Alternate interior. So that's my reason, right? What's their transversal? Let's say that. EJ. EJ is their transversal. So what lines have to be parallel then? You can call it P and Q. P is parallel to Q. Are you guys seeing that now? Again, you didn't have to say P and Q. You could have said line AF and line L or LI, IL, whatever. That would have been fine. Okay. So for this one, I'm not actually marking them congruent because they're not. They're supplementary. Before I even look at the picture, if they're supplementary, what's it probably going to be? Probably consecutive interior, right? Probably. So they said angle DBH. DBH is this one. They're not congruent, but I'm just labeling these, okay? So maybe I'll call that like a 1. And BDK, BDK is this one. I'll call that like a 2. So I know that they're not congruent because that's not what they said, right? Are those consecutive same side interior? Yeah, right? So what's their transversal? P. So the parallel lines are going to be these two, however you want to name them. Do you guys see that? So I called it line CG again, parallel to line EJ. Did I lose anybody on that page? Oh, consecutive interior, right? I didn't write that. We just have one more question. Are you sure you're okay? It's pretty easy, right? It's just backwards of the other day. All right, backside. Find x so that m is parallel to n. What that means is What are these two angles' names? They have a name no matter what. Alternate interior, right? If these are congruent, then those lines had to have been parallel, right? So I'm going to say that they are congruent to make the lines parallel. Do you guys understand what I'm saying there? They're alternate interior angles. If those lines are parallel, they'd be congruent. So I'm making it happen. I'm forcing them to be congruent so that the lines end up being parallel. So solve for x. What do you get? So we're going to subtract x from both sides and get x. 21's still there. 84 is still there. Subtract the 21 and you get 63. Give me just a second. I'll come back and do it slower. Give me just a second. On your instructions, it said to explain or something. For me, alternate interior's fine. I understand where you got that from. So like I said, we're going to skip the proof this year for now. So on your homework, you're going to skip 6 and 26. On your homework, you're going to skip 6 and 26, the two proofs, because you don't know how to do those yet. Okay?